Welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, October 21st. Looking at significant wave heights for the North Pacific Ocean, we actually see a small area of 18-foot seas pushing southeast through the northwestern Gulf of Alaska, and then remnants of a previous system before that with 22-foot seas pushing up into Alaska. It seems we have turned the corner, and the North Pacific, if not waking up right now, is on the verge of waking up, while the South Pacific seems to be going to sleep. Let's get into the details. As usual, we'll start our tour looking at jet stream level winds, but now we're doing only in the northern hemisphere. We're looking for a trough. That is a push in the jet falling to the south, sort of like right there, with decent winds coming into it. That is, winds pushing off Japan, building to, 4, so that's about 170 knots, falling south, and then pushing to the north here. The jet's actually splitting. Part of it's going up into Alaska, part of it's falling southeast, pushing over Baja. This is a pretty typical pattern, especially for this time of year. And typically between the split jet stream flow, you get high pressure, protecting California, Pacific Northwest, as is normal in October. But it is in this trough here that you'll get a counterclockwise flow aloft and down at the ocean surface. That is the hallmark of low pressure, and of course low pressure generates wind. Wind generates seas. Seas, as they radiate away from the fetch area, turn into swell, and swell, when it hits your beach, produces surf. So we have a little trough developing, or at least present, in the northwestern Gulf of Alaska. And it is to continue while pushing east, though losing a little bit of wind energy as we get into Monday, and then kind of fades out. Still, let's see what happens. Little bit more of the trough tries to develop as we get into Wednesday. Notice most of the wind energy is now more in the southeast quadrant of the trough. You really want it on this side of the trough. That pushes energy southeast towards our main forecast area. But nonetheless, there you go. As we get into Thursday, you see a little bit better developed trough, a little bit, actually pretty good area for developing low pressure. That looks decent. More wind energy building into Friday night and Saturday in the Gulf. And that's a small but decent looking trough, nothing epic, and yet more trying to develop back in on the date line as we get into Sunday. Kind of a steep pinched off trough, and more wind energy pushing off of Japan as we get into Sunday night a week from now. And the whole jet generally down, we'll say about at 40 north from Japan the whole way over to, let's say, a point north of Hawaii, and then still in the 45 range as we get over into the far eastern Pacific. Not too bad. It finally looks like fall is starting to set up. So let's see what the forecast is for winds at the ocean surface. We saw the trough right around this area in the upper atmosphere, and that supposedly generates low pressure down at the surface. We have a 984 millibar low over the easternmost Aleutians. Tiny area of 30 knot fetch, not doing a whole lot, not too interesting, and nothing really until we get into Tuesday. Low pressure starts building, 35, almost 40 knot winds. Building, there you go, 40 knot winds, 35 knot winds in the southern quadrant of the low. Building even more to 45 knots as we get into Wednesday morning, aimed northeast. So this is pretty much past Hawaii. Let's go back and actually take a little look here. Yeah, so maybe some sideband energy for Hawaii, but this system, if it develops this gale, looks like it's going to be mainly focused on the Pacific Northwest down into California. And then it too, even into midday Wednesday, 45 knot winds aimed directly at the Pacific Northwest and not too far off the coast there. Building to 50 knots as we get into Wednesday night. So this is actually an upgrade from the previous runs of the models earlier. Tropical system also supposedly forecast in the far west Pacific. Then we get into Thursday, fetch of 40 to 45 knot winds falling south, aimed well at Hawaii, but quickly fading out. And then look at this, the tropical system. Let's go back. In fact, we'll do this whole run here. There's the we'll start it there. There's the tropical system as of Monday night. Drifting northwest, then north, then recurving while another system develops as we get into Friday night off of Kamchatka. 50 knot winds aimed at Hawaii and the U.S. West Coast. Additional tropical energy getting absorbed into that into Saturday. Our recurving tropical system. Oh, look at this. 1, 2, 3 systems of interest as we get into Sunday, a week out. Now, notice most of the fetch in this big one here is aimed not at Hawaii, but somewhere off into the open ocean. But one there. There is fetch, 30, 35 knot fetch aimed at Hawaii, and this system's still back there if it were to develop. Looking very interesting, starting maybe 4 or 5 days out and getting progressively better as we get into next weekend. This is exactly what we want to see. It looks like we went from southern hemi swell 1 week to it looks like what might be fairly decent size North Pacific swell a week later. This is good news. So we look at significant wave height models. We're going back to Friday night, just 2 days ago or so. Tiny small system developed here in the, we'll call it the northwestern Gulf. Little area, 28-foot seas. Probably a big ridge right here pushing it north. Yes, we get 35-foot seas and up to 37-foot seas, but all that's really aimed here along the Canadian coast. Sideband energy probably down into maybe central California, midweek or so. Nothing huge, certainly nothing into Southern California, barely anything into the San Francisco area, we'll say. But also, actually, let's go back. There's this one other little tiny thing here. See that 20-foot seas off of Kamchatka? Now, that doesn't really mean anything, but it managed to sneak its way the whole way across the Pacific to 18Z Sunday. It's in the northwestern Gulf with 18-foot seas. Maybe good for wind swell along this area somewhere out here as well. Also, tropical system developing off of Mexico, but expected to recurve and just push right into mainland Mexico. No swell to result of any interest for California. Baja, yes, but not California. And then moving forward, 18Z Sunday, that's right now. That 18-foot seas pushing north of Hawaii. What is that? 1, 2, 3, 1,200 miles north of Hawaii. Very small wind swell is probably the best that will result from that. Now, here's where things start getting interesting. Tuesday night, notice, what is that, about 22 or 23-foot seas, building to 28-foot seas, but to 33-foot seas by Wednesday AM. We're purposely kind of ignoring this tropical system. These models tend to overhype it, but it just, keep it in the back of your mind. It would be interesting if it does develop. Anyway, okay, so then we get into Wednesday night. What is that, 36 or 37-foot seas? Now, the system is starting to lift north. Will have a lot less effect, but let's just go see just real quick. So there's this arc right here is probably the bulk of the swell generation potential on Wednesday. Looking for possible swell Pacific Northwest down into probably Point Conception or so. Yeah, and then 40-foot seas, all aimed up here in Canada, and very close. Probably, if it were to develop, probably unrideable raw swell except for the most protected breaks. Then here's that next fetch. Remember we saw north winds blowing. Was that 20, 22, 24-foot seas falling south towards Hawaii? That southward motion would push in more swell than you might expect, just given the direction of the winds and the seas. So something to keep in mind there. And then as we get into the weekend, things start getting very interesting. Low pressure developing on the date line. Broad area of 20, 22, 24, let's say 24 or 25-foot seas building. Now notice, see these seas, 28-foot seas out there. Also, another low pressure here developing in the Gulf with 30, 34-foot seas on 18Z Sunday. And we'll just take it out and you go 1, 2, 3 potential systems. Hawaii looks like the bullseye for this broad system. The U.S. West Coast for this system. And who knows where all this is going to go. But there is promise on the models. It's been a long time. It seems like it's been since, April or something since we've seen anything out of the North Pacific. So this is good news. We're not talking wind swell anymore. It looks like possibly real swell is going to develop. That said, let's take a look south. This is the remnants of a system that developed were a week ago, Sunday, October 14th. Swell from this system, it was actually a higher seas. I think they were up to like 34 feet. It's hitting Hawaii. In fact, South Shore looking pretty solid this afternoon. Good long lines marching into all major breaks on exposed south-facing shores. That system faded out. Also, some of this energy will reach its way into California as well. That system died out, but secondary energy developed with 27-foot seas. So a good long run of swell, certainly for Hawaii, lesser for the U.S. West Coast. And yet another system developed behind that on Wednesday night. This is last Wednesday night. So that would be swell pushing into California for the, well, like a week out for Hawaii, so midweek for Hawaii, and probably next weekend for the U.S. West Coast. But you know what? It seems like there'll be bigger swell coming from the north, and it'll probably just swamp this southern hemiswell, except for maybe like Southern California. And that kind of had a pretty good secondary pulse associated with it, too, that went into just about, well, like last night, Saturday sometime, then it faded out. And then pretty much after that, let's see, there we are. Let's go take a look at the future. The next week run, the short of it is the South Pacific just goes to sleep. There's literally nothing of any real interest. That system with 33-foot seas outside even the Southern California swell window. And it looks like the South Pacific's going to sleep and the North Pacific is waking up. We'll take it. So what's going on long term? As usual, we like to look at the Madden-Julian Oscillation, the MJO. That gives us a clue as to what's going on, and it is much more influential in fall and winter months than it is in summer months, so it has yet more meaning than usual. And of course, a potentially developing El Nino, the El Nino Southern Oscillation Index. All clues for what is coming long term. So first up, let's examine what's going on with the Madden-Julian Oscillation. Periodic weather oscillation. It travels from west to east on the equator, and this is the equator. That's New Guinea there. Far west Pacific here. Far east Pacific here, like off of the Galapagos type area. It travels from here, going this direction. When in the active state, that helps feed energy into the jet stream, and when the jet stream gets excited, it creates troughs, and when you have troughs, you have storms and swell. When in the inactive state, tends to suppress energy transfer into the jet stream and does just the exact opposite. So, actual winds. We're looking at winds, looking for signs of the active phase of the MJO. These winds from the TAO buoy array, a series of buoys strung across the equator, used for monitoring El Nino. You look at the arrows, you go, lots of east wind, looks pretty strong, looks like trades the whole way across the equatorial Pacific until you get to the date line, and then the winds either die or there's even a little hint of westerly winds. That is not normal. That is a sign, normally, of the active phase of the MJO. Let's look at anomalies. Well, is this normal for this time of year? Because it's not always the same, right? Okay, easterly winds, pretty brisk. You look at these arrows now. This tells you, well, how much difference is that from this time of year normally? You go, not a whole lot. The arrows are dead. They're pointing north and south, but not really east or west, meaning this is pretty normal over the East Pacific, but in the West Pacific, if anything, there's westerly anomalies. That is a sign of the active phase of the MJO. That might be why the models are suggesting that the jet stream is waking up and that the storm pattern might be improving for the North Pacific. So let's go see what the winds have been doing. This is 850 millibar wind anomalies, so that's up about 4,000 feet, but a pretty good proxy for what's going on at the surface. We're looking, there's the equator, 0. Okay, there's South America, there's New Guinea, Australia, the Philippines. So this area is the equator, but it's specifically what we call the Kelvin wave generation area, the area from 170 west to 5 degrees north and south of the equator over to the far west Pacific. Draw a little box right there. When you see westerly anomalies, that's where we're looking for signs of the active phase of the MJO. Westerly anomalies would be like these oranges and yellows that are not, this was what, 5 days ago, not in the Kelvin wave generation area. So if anything, we were in a weak inactive state, and we just go day by day and look down. Oh, there's a little bit of there's some westerly anomalies. There's some building westerly anomalies. It certainly appears like some small form of the active phase of the MJO is developing. That would explain the energy transfer to the jet and the model's tendency or suggestion right now that things are supposed to get active in the North Pacific. Now, here's a mixture of hindcast and forecast data. This is wind anomalies, same thing, 850 millibar zonal wind anomalies for the whole planet. The area we're interested in is between these. This is the dateline right here. West Pacific, or the Kelvin wave generation between these two tick marks. You just go down. If you see oranges, that's westerly anomalies. So that was probably the active phase of the MJO back in September. And then you see blues, that's easterly anomalies, inactive phase of the MJO. And then as of about, a week ago, we see building weak westerly anomalies. And now for the next week, 5, 6, 7 days. There you go. Okay. Solid westerly anomalies in the heart of the Kelvin wave generation area. A little pocket of east anomalies forecast on the dateline, but this will trump that. And so again, the models are probably picking up on this and going, oh, this looks good. Energy transfer to the jet. This appears to be a building active phase of the MJO. So now we'll try another look, outgoing long wave radiation, okay? If you have the active phase of the MJO, there's New Guinea, of course, Australia, the Philippines, then you would think you would have typically low pressure is associated with the active phase of the MJO, and that would be clouds, and that would be less sunlight reflectivity off the ocean surface, outgoing long wave radiation. But we see yellows suggesting the inactive phase of the MJO and suggesting that it's to build for the next 2 weeks, with the active phase building over in the Indian Ocean. Kind of a head scratcher. That per the statistic model. This is the dynamic model, the GEFS, and it's basically saying the same thing. Well, how can I have building westerly anomalies in the West Pacific when the inactive phase of the MJO is supposedly developing? And there's an easy answer for that. It's called El Nino. Yes, you still have the active and inactive phases of the MJO, but El Nino kind of trumps it. It actually sort of wipes them out, so they're very weak. That this stronger inactive phase of the MJO forecast here is highly suspect. That's 2 weeks out, though. But it would not be surprising to see this sort of a pattern, but still get westerly anomalies in this area because El Nino is supposedly building. Phase diagram charts. Okay, another way to track where the active phase of the MJO is. Assume you're looking down on the North Pole, and the active and inactive phase moves from west to east, from the Indian Ocean, over the maritime continent, like Bali, that area, across the West Pacific, under the United States, on the equator. It stays only on the equator, across the Atlantic on the equator, over North Africa, back to the Indian Ocean. The heavy dot is where the active phase is right now, so it's, let's say over North Africa, according to this. But if it's inside this circle, it's considered extremely weak. The further out here, we've seen some of the active phases get out, out to the outer fringes of this chart, then it's considered extremely strong. So this is almost no active phase of the MJO. And the forecast, see this green line here, whichever way it's going, says it's basically noodling around somewhere in the Indian Ocean, supposed to be extremely weak. Per this, the ECMF model. The GEFS model says basically some flavor of the same thing, maybe 1, 2, 3, 4, 5 or 6 days out, building, just getting outside the cone of death here and into the West Pacific, and then retreating again. So basically a very, very weak MJO signal. The upper level model. Now this, yellows are area not favorable for precipitation. Greens favorable for precipitation. Normally you see a pattern that's sort of over, and this is a 40-day run. Normally you see like yellows going across like that, or greens across like that. What do we see? Not a really discernible pattern at all. This suggests that the MJO, whatever its influence is very weak, kind of muddled, and not really doing a whole lot. Another good sign, especially during fall, suggesting that some sort of El Nino pattern setting up. So let's go to the real source, the CFS model. This is great. This is a long-term model. 850 millibar wind anomalies again. This is the same deal, the whole planet on one chart. Kelvin wave generation area, the West Pacific, you want to call it, right between these two tick marks. There's the date line. Going back in time, you see westerly anomalies. And if you see, you got to see this black heavy line like that. That means the active phase of the MJO. Okay, and the thing that just jumps out is westerly anomalies, continuous from July into September. Good active phase of the MJO here in the Kelvin wave generation area. Here is, so if that's active with the solid contour, this is inactive with the dotted contour, and it looks like we're just about done with the inactive phase of the MJO. Here's the active phase of the MJO. It's been in the Indian Ocean trying to seep into the West Pacific over the next, this is a week, over the next week. Westerly anomalies, the oranges again, westerly anomalies forecast just holding for the next month, next 4 weeks, filling the Kelvin wave generation area, but yet with no real strong discernible MJO signal. That certainly speaks to the development of El Nino. And then you see this purple line here. They call that the low pass filter. When you see it centered in the Pacific like this, that means basically low pressure holding in the Kelvin wave generation area. Now this suggests that a month out it's supposed to be moving east, but we have some other data here to show you as well. Hang on. All right, so here we go. Same thing, only goes out further, and past history is on the bottom here, and the forecast is in the future. 1 second. There we go. All right, so here's today, October 21st. Kelvin wave generation area between these two tick marks going up. Okay, so here we are today. You see westerly anomalies in the Kelvin wave generation area. Forecast building through November and then continuing steady in the Kelvin wave generation area through mid-January. Okay, let's overlay the MJO. What's going on there? Here's our inactive phase of the MJO, supposedly dying out while moving east, as one would expect, with the active phase building. But notice, these are only like 1 or maybe 2 contour events, and for the most part, westerly anomalies persist even during the inactive phase of the MJO. This is a pretty good sign of El Nino. All right, so let's overlay the low-pass filter. There we go. And there is our low-pressure bias. There's the date line. It runs right through the chart here and holds steady through almost the end of January. We had been showing 4 contours, is 1, 2, 3. It kind of toggles back and forth, starting somewhere around December 25th or so. This model is actually the weakest one we've seen in a couple days. Every day it sort of changes up and does something a little different. And when you're talking 2 and 3 months out, you know, you can't really believe it too literally. But the general sense is westerly anomalies continue. This low-pass filter being in the Pacific instead of, oh, and what's this? These dotted lines here. That's high pressure at, like, say, 80 east. That's in the middle of the Indian Ocean. This all is the classic sign of El Nino. Maybe not a super strong one, but an El Nino nonetheless. So we're looking pretty good. So we're not so interested in the MJO anymore because really El Nino is trumping that, and whatever's going on with the MJO is not having that much influence. It seems like the El Nino pattern is driving westerly anomalies in the Pacific and expected to continue to do that. And the models, if you've been following us every week, they've been saying that for months. So this is no big surprise for most of you, but still it's suggesting that all the current data, not forecast data, current data, is pretty much holding along with what the models have been saying all along. Some sort of El Nino developing. All right, let's go take a look in the ocean. West Pacific here, East Pacific here. We're going down in depth. We're looking at subsurface ocean temperature profiles. We're looking for signs of El Nino or Kelvin waves or anything. Okay, warm water in the far West Pacific, 30 degrees. A pretty good push of the 28-degree isotherm line to about 153. I think it's been steady there about a week. We want to see it actually move off to the east more. The 24-degree isotherm line holding at about 103 west. So that's all steady. And, you know, we want to see, instead of this thermocline, you know, being like this, we want to see the 24-degree isotherm line come down like this more and actually push into the coast. But this is just actual water temperatures. It's the trend, differences from normal for this time of year. And what do we see? Warm water, 3 degrees above normal. This is a Kelvin wave. Westerly anomalies I don't remember when it was, sometime a month ago, created a lot of active phase of the MJO. Westerly anomalies took warm water in the West Pacific, pushed it to depth. Here it is, and it travels the whole way under the equator and is now starting to erupt into Ecuador and up to the ocean surface. This is how El Nino gets started. We're seeing all the signs of it here with a large, warm Kelvin wave pushing east. If it was La Nina, you'd see cooler than water normal temperatures here. No sign of that. Again, good news. Here's another version of that same sort of chart suggesting even warmer anomalies. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 5 pockets of 5 degrees above normal centigrade, mostly 4 degrees above normal, starting to erupt on the ocean surface, let's say around the Galapagos. And not only that, there used to be just normal temperatures here. Now this is all 1 to 2 degrees above normal and erupting to the ocean surface the whole way from the Galapagos out to the date line. There's the date line there and beyond. So that's good news. This is what fuels El Nino. Warm water pushing up on the ocean surface in the East Pacific on the equator, where normally there is cool water, and this normally peaks around the Christmas time frame. Anyway, the one little thing that we see that's not so good, see this? Cool anomalies in the far, far West Pacific, suggesting this might be the last Kelvin wave of the cycle. If there was any sense that this El Nino would continue for another year, I'd say probably not. This looks like it's a one-year event, and that unless we start seeing some warm temperatures develop over here subsurface, this is probably the last Kelvin wave of this El Nino. All right, upper ocean heat anomalies. Again, like we said earlier, last year, November, cool. The blues are cooler than normal. This is the East Pacific here, West Pacific here. This upper ocean, upper 300 meters of the ocean's surface. Here was our La Nina, cool waters, a little in January, little mini Kelvin wave that never even made it across the Pacific. Upwelling phase of the Kelvin wave cycle. Big westerly wind burst in February. Pushed warm anomalies, warm temperatures to the east. It reached the Galapagos around the July time frame. Upwelling phase of the Kelvin wave cycle. Here's our current Kelvin wave, significantly bigger than the last one in February. Stronger, broader, deeper, you name it. Hasn't quite made it the whole way across yet. It's at 100 west now, but we would expect it to make it the whole way into Ecuador. And then here is, at a minimum, the upwelling phase of the Kelvin wave cycle starting to develop in the far West Pacific, just like it did, see there? Kelvin wave, upwelling. Kelvin wave, upwelling. And you could see it even there, Kelvin wave, upwelling. Though it's kind of hard to tease some of this data out unless you've watched these charts a bunch. All right, surface temperatures. That's what really matters. It takes warm water on the ocean surface to create evaporation. Evaporation transfers energy into the jet stream, and that in turn feeds the jet stream and helps create troughs and therefore gales and storms. All right, so this is actually very encouraging. We see warm water building the whole way across the equator, and this is really cool because it's not only north, aligned north, but mirror imaged south of it as well, down about 5 degrees south, 5 degrees north. The official El Nino monitoring region is from 120 west, so from here out to 170 west, 5 degrees north and south of the equator. We certainly see some above normal temperatures, but you really want those warm waters to extend the whole way into this area to be, you know, a really good, legit El Nino, and to also help positively affect precipitation in California in the winter months. So El Nino is really about, officially, it started by fishermen in Peru noticing temperatures in the Christmas time frame getting warmer than normal, driving their fish away. And so El Nino wasn't a good thing, and it would actually create rain into Peru, which is a pretty unusual sort of event. So we're looking for warm water here. Yeah, we see a little bit. It's not super pronounced. and given the time of year that we're into October already, you would think it'd be a little bit broader and more defined in this area, but we've never said that this was going to be a big El Nino by any stretch, but just, we'll call it a modest to moderate El Nino. It's sort of like a normal everyday garden variety, which typically doesn't have a super big impact on California rainfall. What it does do is feeds the jet stream, though, and given 2 years of La Nina, anything to get us some winter surf, we'll take it, and this is exactly what we need. Now here's the trend for the past 7 days. The good news is temperatures had actually been cooling. There was blues all around in here last week. That's all gone now. We're starting to see a couple little popcorn, weak indicators of warming along the Peruvian coast and Chile for sure. And warming again starting to develop on the equator, both north and south of the equator, a couple of degrees north and south. So things looking, it's almost like we went through like a little mini inactive phase of the MJO. Trades kicked up, kind of stomped on this warming for about a week, but now it's coming back, and the sense is that maybe some, if not the active phase of the MJO, at least El Nino is starting to take over and stomping on any enhanced easterly trades in this area, and that will help more warm water move up to the surface. And then here's the overview. You can see it clearly. Warming all along the coast here, the whole way up to Ecuador. A little bit of warming along the coast of Peru. You really, if it's like some big mega El Nino, you would see literally a triangle that goes like this down to here, and all this would be yellows and oranges, if not reds. We're not seeing that. That's why we say, well, this is looking very much like just a weak El Nino, but that's okay. It's better than La Nina. We'll take it. So surface temperatures in the Nino 1.2 region, this is actual temperatures, not a forecast, actual temperatures. You see back in the summer, they were below normal. And this is the area right up there along Ecuador and Peru. And then we got this kind of a warm spike late September or so. And then we said, yeah, well, maybe the inactive phase, the MJO is having an effect. Well, you can see that clearly. We're down into minus 0.539 degrees today, where we were up at almost plus 1.2. But this doesn't necessarily, this is not the official El Nino monitoring region. This is the Nino 3.4 region. Temperatures hovering at about 0.2 degrees above normal, which is basically just normal, until the end of September. That's when this big Kelvin wave started showing signs of erupting, and it was up to about 0.8 degrees, a little above 3/4 of a degree above normal. Now, the past week, these are week-long tick marks here, it went down some, but we think the temperatures are going to start going up again. This is attributable to the inactive phase of the MJO, or a weak easterly wind burst, not even that, just easterly winds a little bit enhanced in the Galapagos region. That appears to be dying out now, so we expect these temperatures to start going up. But today, 0.459 of a degree above normal, so half a degree. All right, so what's going on in the atmosphere? We talked subsurface temperatures. We talked surface ocean temperatures. Is the atmosphere responding at all? Well, okay, so we look at the Southern Oscillation Index, difference in pressure between Tahiti and Darwin, and you get a index. They read it every day. You get an index. When the index is negative, today, minus 6.96, that suggests, if you get a bunch of those, like for 30 days, that suggests the active phase of the MJO. If you have positive numbers, you can see we kind of were pretty much negative, and then for the past week we've been positive. So we're saying this was like, there's some like mini inactive phase of the MJO. Now we're starting to go negative again, and water temperatures are starting to warm. So if you really follow this stuff close, you can see little pulses in the atmosphere, and the interaction of pressure and ocean temperature and all that contributes to El Nino. Anyway, 30-day average takes all the noise out of it. Today, minus 2.4. Still, you want to see it. It was actually lower. You can see it went down to minus 10.6 there at one point. That was during the peak of the last active phase of the MJO. It'll take a couple of days to catch up, but our guess is this is going to start going negative again. The 90-day average really strips out all the noise, and this is what you use for monitoring El Nino, La Nina. You can sit here and look. It's been like anywhere from 3.5 to let's say minus 4.5, and not deviating a whole lot. So this is no clear sign of El Nino yet in the atmosphere, though we see all the signs of it trying to get going in the ocean. So the ocean and the atmosphere are not coupled yet. The storm cycle that's projected in the North Pacific is probably more just the normal fall transition. But what this is also saying is we don't see any signs of La Nina, because if there were La Nina, this would all be positive. It's not. If anything, it's biased very, very weakly towards El Nino. We want to see this guy go down to like minus 8 or something like that. Then we could say, yeah, El Nino is here. It might be weak, but it's here enough that it would be affecting the jet stream over a long period of time. And then there's one other index, same sort of deal, different, but instead of difference in pressure between the area north of Darwin, Australia, and Tahiti, this is actual amount of rainfall. That matters more than pressure, right? If you have more rainfall than normal here, then the index will go positive. Right now, it's at minus 0.04. So basically dead neutral, saying, yeah, it's not dry in this area, but it's not wet either. It's just like a normal year. And that's what the SOI was just saying, that last index we looked at. And everything else is sort of suggesting, yeah, you know, La Nina's dead, and we're moving towards El Nino, but we haven't made it there yet. We think, now, what the numbers don't say is, we think we're going to get there. It's just, it takes a long time to go. It'll be another month or two before the atmosphere really wakes up, probably sometime in the late December, early January time frame. But if El Nino does develop and water temperatures get warm enough in this area, if you have warm water in this area, you'll get more precipitation in this area because you have more evaporation than normal. Pretty basic stuff, right? And then that'll start feeding the jet stream. So from a surf perspective, what this means is, yeah, we'll you know, we've had a late start to fall. That's probably because La Nina's been hanging around. That's gone now. We're moving into a more normal pattern. And if we're going to see some enhanced pattern from El Nino, probably won't be till Thanksgiving or even early December kind of time frame at the earliest. Still, we'll take what we can get. And then finally, the forecast for the Nino 3.4 area, sea surface temperatures. All right, so today we're at, we say about 0.4, which is down here somewhere. The model says we should be up at 0.8. Yeah, okay, so I could say, I'll stretch it a little bit and say, well, yeah, okay, so we had a little, like, inactive phase of the MJO that knocked temperatures down temporarily, but we got a long ways to go. We need to be back up to 0.8 and holding, so as we get into, let's say, mid-November, temperatures should be 1 degree above normal, and about 1.1 degree peaking out in the December, January time frame, even into April, and then fading from there. So even if this was fully achieved and we got, let's say, 1 to 1.1 degree above normal temperatures, that would certainly qualify as an El Nino. All you need is ½ degree above normal. We're almost there now, but you got to do it for basically, 5 or 6 months running, something like that. Okay, we're not anywhere close to that yet. By the time they officially declare El Nino, winter will be over and we'll be into, mid-spring or something like that. Still, the forecast has not changed much. The temperatures have gone down maybe 1/10 of a degree from last week. So, still, no big change. So, to wrap it up, southern hemiswells are in the water, hitting Hawaii, and I think there's 2 more behind that still to go, and some of that energy is going to be reaching into California as well. And at the same time, it looks like the North Pacific is waking up. Small swell is already in the water, probably targeting mainly Northern California up into the Pacific Northwest. Nothing big, but the models suggest over the coming week that pattern will change significantly. The South Pacific is going to go to sleep. Probably not a whole lot of activity after that, and that's kind of normal for this time of year. North Pacific is supposed to wake up, and we might actually be getting, or at least moving towards a pattern of real surf. El Nino, still developing, weak, but trying to get its footing. At least La Nina is gone, and all the models suggest, yeah, we'll get some enhancement from La Nina this winter. Regarding California snowfall and rain, that's not at all a sure bet. One would assume a normal precipitation year. Nothing more, but nothing less either. So, that's it for this week. Good news, at least. We'll do it again next week. Same time, same channel. Thanks for watching.